All right, so we're going to first factor these. So I'm going to do x and x. And does that one factor? Yep, to what? What is it? What's wrong with you? Come on, factor. What is that? -3, +1. Okay, next thing. Holes. Are there any holes? No. Why? Nothing crosses out. So if I could cross something out here, there would be a hole, but I can't. So there are none. All right, vertical asymptotes. Where do those come from? From the bottom. You set the bottoms equal to 0 and solve. So set whatever you have left on the bottom. Why do I say whatever you have left? Because if it's a hole, it's not an asymptote as well. So where are my asymptotes? X equals 3 and x equals -1. And what about horizontal asymptotes? Look at your chart. Why? Because bigger on bottom. You look back at this one. The exponent on the top is nothing. There's not one. And then the exponent here would be 2. So bigger on bottom, y equals 0. Any questions? All right, now you're going to sketch it. So go over to your graph and sketch it. So on this graph, you're going to sketch the hole first. Is there a hole? Excuse me, you're not going to be able to sketch the hole at all. Not at first. You can later, but not right now. So hole will have to come at the last. What about the vertical asymptotes? X equals 3. What kind of line is that? Dotted, and it's a vertical line, so it would be right here at 3. Are there any questions on that? Where's your other vertical asymptote? -1. What's your horizontal asymptote? You shouldn't mess up on horizontal and verticals because vertical means up and down and horizontal means straight across, right? All right, what's my domain? All reals except 3 and -1. Where are those coming from? The vertical asymptotes. All right, what's the definition of asymptotes? They get close but don't touch. So get in your calculator. Because you know that definition, whatever your calculator gives you, you're going to be able to decipher, hey, I don't know exactly what that looks like, but I can get a pretty good sketch. So 1 divided by x squared minus 2x minus 3. And you hit graph. What you think? Where would I sketch it? What would I do? I have to have something in every single segment, like every single piece. Where would I sketch it? Okay, this corner, this corner, and where's the middle part? Does it go this way or does it go this way? Goes down. Do you see how to see that in your calculator? If you hit zoom in one time, it's probably going to help you. Oh, for sure help you, right? Well, sort of. You can change your window at that point because you need to be, let's see, at least 3. Did everybody see how to manipulate that graph? Thank you. Thank you. All right, let's do number 2. All right, what's the first thing that I do? Factor. So does the top factor? Does the top factor? Does the top factor?
Yes.
Yes. What's the GCF? That's your first rule. 3. Does the bottom factor? Yeah. What does it factor into? X plus 1, X minus 1. Any questions on that? All right. Let's do a whole. There's one at -1. What crosses out? So this goes away. So because that goes away, I set it equal to 0 and solve for x. So there's a whole at -1. Does that make sense? What about 2, or vertical asymptotes? X minus 1 equal to 0. Why don't I set the other one equal to 0? Because it canceled out. It was a whole. Can't be both. All right? So what's the vertical asymptote? X equals 1. All right, now let's do horizontal asymptotes. Am I going too fast?
No.
All right. Look, which one do I look at? Do I look at my factored one or my original? Original. Look at your notes. What example is that? Bobo. Okay, so if that's Bobo, it's bigger on the bottom. So what's the asymptote? Y equals 0. Bobo, the 0 is at the end, right? All right, sketch it. You have to sketch this, but you got to wait till the end, okay? All right, sketch the vertical asymptote. What is it? 1, vertical at 1. What's the horizontal? 0. So it's here. All right, get your 83. Put that in. When I'm doing this, you have to remember the definition of an asymptote again. It's going to get close to what I just drew, but it's never going to touch them, never going to touch them. Y'all got to hear this song, so I'm doing it a lot of justice back here. Go ahead and hit zoom 6 so you can kind of see what it looks like, okay? Is that vertical line there?
Yeah.
Well, yeah, it's there, but what is it? It's the asymptote. It's not part of the graph. So you should sketch this here. Is everybody okay with that? Now, after you get the sketch, you have to deal with the whole. Where is the hole? At -1. So at x equals -1, watch what I'm going to do. This is not going to be perfect because we're just sketching these. But at x equals -1, right there is x equals -1. Go to your sketch. And draw a circle. What happens is that is one part missing out of that. So you could technically just erase a little bit of it, and that circle would mean, hey, I go right up to it, but I don't equal -1. Does that make sense?
Yes.
Any questions? I feel like we need to do one more, and then I can let you loose. Let's do number 3. Oh, we didn't do domain. Thank you, Katie. All right, what's the domain of this one? Thank you. All reals except x equals 1 and -1. Where's the -1 coming from? The hole in the vertical asymptote make it change. Do you remember how we did the range yesterday on that one? Well, who remembers? Raise your hand. I'm not going to go over it then. Any questions? Millicent, are you good? Okay.
My graph looks different though on the computer.
Hit zoom 6. I zoomed in, Millicent. So if you zoom in one time, see if it looks the same. If not, I'll come over there in just a second, okay?
Yeah, it still looks different.
Okay. Shh. Yes. So the hole, what you do is if I have a hole at -1, you have to do that after the sketch. So once you sketched it, like you sketched it and you had this, right? A hole happens when x equals -1. So you're going to go to x equals -1, which would be here, and you're going to go where the graph is at -1, which is right here. Does that make sense? On yours, Julia, it might be somewhere different, but it should be under the x-axis anyway. So you just take that little piece out of the thing that you just sketched. Does that make sense?
I figured out what was wrong with I had put it in the equation.
Okay, good. I mean, not good, but that's an easy fix. All right, any questions? All right, let's look at 3. All right, number 3. What's the first move? Factor. So what is the top factor to? Yep. What's the bottom factor to? Pull a 4 out and you have x plus 2. Does everybody see that? Is everybody okay? All right, what about holes? There's no holes. Why?
Because nothing marks out.
This looks like it crosses out, and that's a tricky one because they'll want you to screw up on the factoring there. Okay? So be careful. Making sure that I'm not going over factoring because that's something we should know. So I'm putting the right answer almost every time. But you need to, when you're by yourself, you need to FOIL it out and make sure it does multiply to be that one or this one. All right, so there's no holes. Vertical asymptotes.
Not
I set the bottoms equal to 0. So 4 equals 0 and x plus 2 equals 0.
You got negative.
What is this? What happens to this one?
It just marks out.
It goes away. There's no x. And then I have x equals negative 2. All right. What's the horizontal?
Greater than 0.
Bigger on bottom, bigger on top, or equal? Bigger on top. So bigger on top is no.
It's bigger on. No, both sides.
So no horizontal asymptote.
No.
What'd you say, Isaiah?
Oh, I was just running my mouth.
Well, this is the one you look at. The x.
How did you get to the no horizontal asymptote?
This 2, this x. You're looking at this 2 and this 1. Because those are the exponents on the top and the bottom. So it's bigger on the top. So look at your notes. No, bigger on top, no asymptote. Any questions? Okay, what's the domain?
All real. Except 2.
All reals
Except negative.
except x equals negative 2. That's coming from the vertical asymptotes in the holes only. All right, what's the vertical asymptote? So I go to negative 2 and I sketch it. Now, used to way back when the slant asymptotes were in your curriculum, this 2 is only one larger than the one on the bottom. So there is going to be a slant asymptote, but we don't have to find it. Okay? So let's go ahead and go to our calculator and sketch it. There's no horizontal asymptote. So that's why I'm not sketching one of those. Now, I've kind of fibbed to you a little bit.
You kind of what?
Fib to you a little bit. The definition of an asymptote, I've told you it never touches it, correct? The definition of an asymptote in this classroom is that it never touches it. When you get to more complicated stuff, it can touch an asymptote eventually, like in some pieces. All right, do you see what happened there? So, I mean, honestly, just give me a good sketch. It does not have to be perfect. I just want to know that you know that there's no horizontal in that one and that there is a vertical. Do I have any holes in that one? No. Can someone tell me the range in that one? Are there any restrictions going this way? Nope, that's the domain. That's going left to right. There's no restrictions going up and down. All reals. All right. Okay, look at, I'm going to give you a break right now in just a second, but look at number 4 before I give you a break. Do you see where that negative is on number 4?
Yeah.
I want you to put it on the top. So make that positive and just put the negative with the 2. All right, you may take a 2-minute stretch break, and then I want you to come back and just start doing problems.
On 11 and 13, you also move the negative to the top too?
Yeah, any of them that have the negative, move it to the top.